Hello, my name is Lewis, and for this video I'm going to explain the results of the Nmap Network Intelligence Exam. This was an exam that was given to me in order to analyze my local wireless network so I can explain strengths or even the effects of port scanning in my local wireless network. So let's start explaining the answers. The first question is, how exactly does port scanning affect the network performance in my network? And in order to explain that, I need to construct a metric estimating the maximum port traffic in and out that each device on my local wireless network can manage without loss or meaningful degradation in performance. And based on that assumption, I have to explain the error. In my case, in order to create the metric, there are three parameters that I have chosen. The first one is the window size. The window size is a variable that is advertised either by the sender or the receiver in a TCP connection in order to tell the host, the first host or the second host, how much information the device is going to handle or how much information it is able to receive. In this case, the window size is normally expressed in bytes. However, I'm going to express it in bits because I need to operate the window size with units that are different. The second variable is the round trip time or latency. That is a very important metric when we are defining the health of our network. The round trip time is the variable that we are going to use because in a TCP connection, the only way that a host has to know that the information that was delivered successfully is by getting the round trip time, because in this way it knows that the information was able to reach the sender, and then the sender notified the host that the information was delivered successfully. Normally, the round trip time is expressed in milliseconds, and we are going to keep that variable with that same unit. Then, the third variable is the maximum segment size that is expressed in bytes. In this case, for this metric, we are going to express it in bits. For this metric, the maximum segment size would be equal to 1460. That is the default size for the maximum segment size, unless a person or a network administrator or anyone that knows about how to configure the network card change that value. And my metric here below tells that the maximum port traffic in megabits per second would be equals to the average window size divided by the maximum segment size multiplied by the round trip time, and all that divided by 1 million. And the reason for that is that the maximum segment size tells that how much information can be sent at a given point. In this case, even if the window size is a very high window size, the TCP protocol is only able to send a data package that is of a size of 1460, and that's why we are dividing the window size by the maximum segment size, because it is going to receive only one segment at the time. And then we multiply that by the round trip time, because as I said before, that's the only way that the host has to know that the information was delivered successfully. And finally, we divide that by 1 million because we want to express it in megabits per second. On the other hand, the error is easy to explain because The a number of error in a TCP connection is basically defined by the number of retransmissions. So basically the error would be equals to the number of retransmissions divided by the number of data packets that were sent in that connection. And this is just a chart that I put before in order to explain how the window size works. It was basically what I have explained before. When a host A sends a petition to the host B is going to advertise a Windows size. In this case, the Windows size is 16 kilobytes, which means that since it is 16 kilobytes, the host is able to send 11 frames or data frames of 1460 bytes. As you can see, there is a difference because kilobytes and bytes are different units. So that's why you can get that same unit by dividing or by multiplying by 1024. In this case, just to show you an example, I'm gonna open the calculator. We have 16 kilobytes multiplied by 1024, and that would be divided by the maximum segment size, that is for 1460, and that will be equals to 11. That is the same number of segments that the host is able to send. Host A is able to send to the host B, and the window size once the buffer is full, the host B is going to advertise a new Windows size to the host 8. In this case, it increases the size. But what happened? Just in the case that the device is under congestion, that window size would be reduced. But that's the job of the network card to tell the TCP protocol to transmit that information to the host A, so the host A can reduce the data rate that is going to be sent from that same host A to the host B. Now I can in order to explain the metric, I made a shell script that can capture traffic and another shell script that can analyze the traffic that we are going to capture in order to tell how much information our host can handle. In this case, the name of the script that is going to create the capture is the metric script.sh. So let's run it. In this case, the script is going to ask you for a file name. So basically, the name of the capture. Let's say that it is going to be called capture 1, 2, 3, and the path where I want to store that information. In this case, this home. And once we hit enter, the capture is going to start. So basically what you can see there are the number of packages that are being captured. What you can do is that you can generate some traffic by downloading a file. In this case, this is a web page where you can download test file in order to test your network or any other network metric. In this case, I tried using 200 file, 200 megabyte files. However, you can download other very large file in order to get a better understanding or a better or one a more accurate result about the maximum port traffic of your device. Since I have already done a capture, I'm gonna stop the script and I'm going to run the second script. That is a script that is going to read the capture and then perform the metric in order to tell how much port traffic our devices were able to handle. In this case, the script is called capture processor, and the name of the file was air capture. I'm gonna filter that result so we can read it one at a time. In this case, I'm reading the file that I downloaded before. In this case, you can see that you have different hosts and the average window size, the average round trip time, the total amount of data that was in that device and at a given point, and the throughput of the host. So basically the capacity of receiving and sending information at a given point. In this case, that's not our host. I think that's my router. So you have to find out which is your local IP address so you can observe what is the throughput of your device. In this case, my IP address is 192.168.0.108. In this case, the average window size was 1283. The average round trip time was almost zero. That's expressed in milliseconds. The total data that was in the network in the device and at a given point was 0 megabytes. And it also tells that there wasn't a significant transmission error at a given point, and the host throughput is 1 megabits per second. So basically, in this case, by using the test file that I have downloaded before, the maximum port traffic that my device was able to handle was 1 megabits per second. And after that, you can tell that my device was in a situation where it was suffering congestion. As you can see in the script, there are many other devices that are in my network. There are others that didn't have errors. There were others that experienced errors, and as something extra that I put in the script, there is a network resource section that is basically the overall throughput of the network. Basically, what I'm telling is all the amount of information that was in the network, but taking in mind all the devices that are connected to my local wireless network. In this case, the maximum throughput was 8 megabits per second. So that's a very interesting metric, because that's almost the amount of information that my service provider is providing me, because my connection is a 10 megabits connection. So In my opinion, you can tell that because of that, you can say that this metric is fairly accurate in order to test the port traffic of your device. And another advantage is that all the devices that are connected in a network, either a Chromecast TV, a tablet, a printer, all the devices have a network card, and then that network card advertises a Windows size. So basically, you can use this metric with any device. In this case, I didn't try the other devices because I don't have them. However, I had my tablet. And another advantage is for me in my case is that my network card supports a mode called monitor mode that allows me to capture traffic of other devices in the network. In this case, even though I don't have Wireshark or a data capture interface in those devices, I was able to capture that traffic because my network card allows me to do that. And with that, I finished the first part of that question, and then we can go to the second part, that is how exactly does port scanning affect the network performance in my local wireless network. In this case, after analyzing my local wireless network, what I can tell is that the Nmap doesn't cause a congestion in my network, and the reason for that is because of how Nmap works. Because when Nmap is analyzing a network, what it does is that it sends a data package of a fixed size. In this case, it normally sends a 56 bytes data package, and that single data package will be directed only to one port. And once it gets to that port, the receiver is going to send a notification to the sender, so basically to the person or the host that made that scan, and tell you if and based on that answer, the Nmap is going to tell if the port is open or not. So basically, when Nmap send that data package, it also advertises a Windows size, and the receiver that is thinking that a connection is going to be established also sends a Windows size with the response. However, even if that Windows size is advertised, Nmap doesn't send traffic. So basically, you are not consuming the resources that you are asking, and that's why even if you perform the many different type of scams, you are not creating congestion in the device. It's not, and the Nmap is not going to cause a problem in the device, because you are not having an actual data exchange. However, by their nature, you can say that there are few scans that takes less time in order to be performed. The first one is the TCP scan. The second one is the XMAL scan. The third one is the NOR scan. The fourth one is the FIN scan. The fifth one is the SYN scan, and the sixth one is the UDP scan. That is a very very low scan and put a lot of data packages in the network. So what I'm trying to tell in this point is that basically the Nmap by itself doesn't cause congestion in a device. It doesn't cause problem. However, what Nmap can do is that it can put a lot of data packages in the network that can in some way consume resources. For that, I have made a metric that can help you to figure out how much information you are putting on the network. Basically, there are a few many important options that you can optimize in order to create a custom scam. And that's why I'm telling also that it doesn't matter what type of scam you use. You can use, for instance, seeing a UDP scan that is a very low scan by default. You can make it a lightweight scan, almost as lightweight as the TCP scan. So that's why basically I'm basically saying that it doesn't matter what type of scan you use. You can customize the scans according to your needs. And then this is the metric that I have made in order to calculate the load that would be in the network, and that would be the size of the data package in bits or bytes, depending of how you want to, in what unit you want to express that result, and you multiply that by the number of ports, basically how many ports you want to scan at the same time, and that would be multiplied by the number of hosts. In this case, I'm going to use a worst case scenario to show you that a Nmap scam doesn't impose a heavy load in the network, which means that it doesn't cause like a very detrimental effect in the network. In this case, let's assume that we have a 56 bytes in a data package, and we are going to send that data package to, let's say, to 1000 ports, and we are basically going to send 56,000 data packages, and now we are going to multiply that by the number of hosts. Let's say that you have a huge business, a huge corporation. You have, for instance, let's say 1,000 hosts or 10,000 hosts. And now I want to spread. Let's say I want to, for a better understanding, I want to express that in megabits. So let's see. So basically now we are converting to kilobytes. So divided by 1024, and now 2 megabits. I think I made a mistake in this part. So let me try the example again. 56 bytes multiplied by 1000 ports that I want to scan, and that multiplied by 1000 hosts. And now we are that's basically in bytes. We are going to divide by 1024. That's kilobytes. And now we are going to divide that by 1024 in order to express it in megabytes per second. It's different. No? Megabytes and megabits are different. In this case, we are expressing them in megabytes. Oh, so it seems I made another mistake. So divided by 1024, and again 1024. What I'm trying to explain in this line is that basically, even though you are sending that huge number of data packages, you are basically only sending 53 megabytes to the network. And you can just think about this. So let's say that you have a 10 megabits connection. in your local wireless network. Now imagine a corporate network that can have a gigabit, 400 megabits or so. So basically, what I'm trying, my point is that even though you are scanning that huge number of hosts and ports at the same time, you are putting a very little load in the network. And based on that is that I'm saying that an Nmap scan doesn't cause congestion. Plus, the information that I have read in internet that network administrator have provided, it confirms my theory. What people say is that sometimes Nmap can cause a problem in a program, is if only if that program is poorly written. That's the only case in which you can find a network problem in a host. But otherwise, in my opinion and according to my research, Nmap doesn't create a huge impact in the performance of my network. And with that, I hope you understand the points that I tried to make. And with that, I am finishing the first part of the test. If you have any question in the future, you can tell me or we can discuss that, since my answers are not absolute.